a scale product for coffee pot. The main constituent of a scale product is sulfamic acid. A scale product هو مادة باودر تستخدم لتشيل التحوير عن الازاز والستانلس اللي هو عباره عن سترونج اسيد. فينا نستخدم الحامض، فينا نستخدم الخل نحن بالبيت. بالجليات بيستخدموا نوع من البرودكت اسمه sulfamic acid. It is sold commercially as white small crystals. The aim of this exercise is to determine the percentage of sulfamic acid in the scale product by pH method. Given sulfamic acid of formula NH2SO3H will be represented as HA in this exercise. يعني ما بدنا نستخدم الفورمولا، نستخدم HA. Molar mass of sulfamic acid in gram per mole equal 97.1 gram per mole. Experimental procedure. First step, 2.05 gram of this scale product, of this powder, are dissolved in distilled water to obtain a solution S of volume V equals 500 milliliters. 2.05 gram is not the mass of sulfamic acid, it is the mass of powder. Among the constituent of this powder, we have the sulfamic acid. يعني هيدي 2.05 منا sulfamic acid على الحل، هي sulfamic acid وشيء ثاني. نحن بهمنا من اصل 2.05 جرام كم جرام منهم هو sulfamic acid. هذا اللي بدنا نطلعه من خلال التايتريشن. Second step, a volume VA equal 10 milliliter of solution S is put into a beaker. A volume V prime of distilled water is then added to immerse the electrode of pH meter. يعني عم نجهز للتايتريشن. Third step, titration is carried out by using sodium hydroxide solution of concentration Cv equal 410 negative 2 mole per liter. خلينا نكتب الجبن وبعدين نبدا بالاسئله. Exercise 8, we have scale product, a mass of powder equal 2.05 gram. We prepare a solution S, and V equal volume prepared equal 500 milliliters. Then from S, we titrate sulfamic acid represented by HA. HA of concentration Ca to be determined. We take a volume Va equal 10 milliliter of S that contains the sulfamic acid HA. We titrate the sulfamic acid HA in the solution S. We take 10 milliliter of S. We titrate it using sodium hydroxide solution Na plus HO minus of concentration Cb equal 410 negative 2 mole per liter. Now, preliminary study 1.1, sulfamic acid is a strong acid. Write the equation of the reaction of this acid with water. 1.1, strong acid, that means its reaction with water is complete. Sulfamic acid is represented by HA. We put HA instead of its formula, plus water H2O. Complete reaction gives H3O plus A minus. This is the equation of ionization of this strong acid, sulfamic acid in water. 1.2, indicate the appropriate material used to weight the mass of 2.0 gram what do we need to weigh the mass? We need a digital or precision balance. We use a precision balance to weigh 2.05 grams. And we use watch glass and spatula. Prepare the volume V. We need a volumetric flask of capacity 500 milliliters. Without the volume VA, we need a volumetric pipette of capacity 10 milliliters. Add the sodium hydroxide solution. We need a graduated grade 0.5 or 50 according to the volume at equivals. It is preferred to use 50 milliliters since we don't know the volume at equivals at this instant. Then, to weigh we need precision balance, we need a spatula and watch glass. Second, to prepare solution S, to prepare 500 milliliters of S, we need volumetric flask of capacity 500 milliliters. To take or withdraw 10 milliliters of S, we need volumetric pipette of capacity 10 milliliters. To add the NaOH solution, graduated grade. .5 or 50 milliliters. If volume at equivals less than 0.5 milliliters, it is preferred to use graduated grade 0.5 milliliters. If volume at equivals bigger than 0.5 milliliters, we should use a graduated grade 50 milliliters. 1.3, write the equation of the titration reaction. This is a titration of a strong acid represented by H3O plus by a strong base HO minus to give 2H2O. This is the titration reaction. 1.4, based on the chemical which are present in the beaker, justify the value of pH equals 7 at the equivalence point. 1.4, the chemical species present at equivalence are Na plus from sodium hydroxide, A minus from sulfuric acid, sulfamic acid, and H2O. At equivalence, we have no H2O plus nor HO minus. Na plus and A minus, the cation of strong base and the anion of the strong acid are indifferent or spectator ions. It remains H2O. H2O is neutral. Then pH E equal 7. This is part 1. Part 2, make use of the titration result. Part of the titration result is given in the following table. We are given pH, initial pH, 7, that means 10.4 is what? When pH equals 7, the corresponding volume is the volume at equivalence. Then VBE equal 10.4. And the final point, 50 milliliter, pH equal 11. 1. Though the shape of the curve pH equal function VA for VB between 0 and 15 milliliter, take the following scale: 1 centimeter for 1 milliliter in abscissa and 1 centimeter for 1 unit of pH in ordinate. The shape of curve is أنا كنت سبق رسمتها. Okay. Maybe part 2.1. Then the initial point is 0, 2.4. The equivalence point 7 and 10.4, and the final point volume equal 11, pH equal, volume equal 15. Correction. For V equal 15, pH equal 11. The curve is ascending, formed of 3 parts. The first part is a flat line رسمتها بالمسطرة، فيكم ترسموها بالمسطرة بس ascending طالعة مش horizontal. شي سنتي بتطلعوها قبل equivalence point على الجامب اوف بي اتش بتفتلوها، فيكم ترسموها كمان بالمسطرة ميلي شوي مش فيرتيكال 100%، وبعدين تفتلوها قبل الفاينل بوينت تفتلوها شوي، وبالمسطرة فيكم ترسموا الفلات لاين الثاني البارت 3 of the curve. إذا هذا shape of the curve. ولاحظين بتكون المسافة من هون المسافة من بداية الطلوع للإكفالنس بوينت تكون قد مسافة من هون، يعني تكون الإكفالنس بوينت بالنص مش فوق ولا تحت لتكون رسمتكم مضبوطة. Okay, now 2.2. Determine the concentration Ca of sulfuric acid in the solution. Calculation at equivalence. At equivalence, number of mole. Sulfuric acid is a strong acid. When we have strong acid, we put number of mole of H3O+. Introduce to beaker. Equal number of mole of HO- strong base HO- added. Number of mole HO plus CaVa, number of mole HO- CbVbE. Ca equals CbVbE over Va. We have said that the volume that corresponds to 7 is the volume at equivalence. Then V equals 10.4 is the VBE equal to 10.4. CB is 4, 10, -2. VBE equal 10.4 over VA equal 10. 10 -2. But 4 times 1, 4.16, 10 -2 mole per liter. This is the molar concentration of sulfonic acid in the prepared solution. Three, deduce the mass percentage of sulfonic acid in this scale product. The mass percentage 3% by mass of sulfonic acid equal mass of the sulfonic acid over the mass of powder, dissolved powder, times 100. This is the percent of the sulfonic acid in the powder. The mass of powder is equal to 0.05 gram in a volume 500 milliliter. To what is equal the mass of sulfonic acid in 500 milliliter? That means in 2.05 gram, how many gram of sulfonic acid? Using the concentration determined by titration, we can deduce the mass of sulfonic acid in 500 milliliter. Then we have C equal N over V equal mass over molar mass times V. Then the mass of sulfonic acid equal concentration times molar mass times volume. This is a molar mass. C equal 4.16 10 -2 times molar mass of sulfonic acid is given in the exercise equal to 97.1. 97.1 times the volume prepared equal 500 milliliters, that means 0.5 liter. 2.019. Okay. Percentage by mass of sulfonic acid equal mass of sulfonic acid 2.019 over the mass of the powder equal to 2.05. 2.05 times 100. 0.5 that means 0.50 equal كمان شوفوا لنا هذا البرسنت بيطلع بال 90 كذا برسنت قد بيطلع الجواب 98.5% of this powder is sulfonic acid. يعني كل 100 جرام من هالباودر في 98.5% هن sulfonic acid وال 1.5% هن اشياء ثانيه بيكونوا additives زيدينهم لهالبرودكت. هذا percent by mass للباودر لسوليد بقلب سوليد، يعني لسوليوت بقلب الباودر بهالطريقه. هيدي الماس لسوليوت على الماس للباودر ضربين. الماس للسوليوت بنجيبها من خلال الكونسنتريشن لما اللي طلعناها بالتايتريشن، والماس للباودر هو بيكون معطينا اياها رسمناها. Okay, this is part 2. Now part 3, last part of the exercise. Effect of dilution on the pH measurements. A solution S prime of the scale product is prepared by diluting solution S 10 times. That means part 3, the S of C, we take a volume V to prepare the solution S prime of C prime and V prime, and F equal 10 times. 3.1, among the following kits, choose by justifying the kit that should be used to carry out the most precise dilution of solution S. We know that we have dilution, then after dilution 3.1 and solute is conserved, then N solute equal N prime solute, then CV equals C prime V prime. Therefore, F equals C over C prime equal V over V prime over V equal 10 times. V prime is the capacity of the volumetric flask. V should be the capacity of the pipette. We should choose a volumetric flask and pipette of the ratio equal to 10. For kit 1, 100 over 10 equal 10. F is realized, correct, but we used 100 milliliter beaker instead of volumetric flask. Then preparation of kit 1 is not convenient for this preparation because we don't use a beaker to prepare a solution. For kit 2, 10 milliliter volumetric pipette, 100 milliliter volumetric flask, 100 over 10 equal 10. We have 10 times dilution and the glassware are precise, then kit 2 is the convenient one, the most precise one. For kit 3, 10 milliliter graduate cylinder, 200 milliliter of volumetric flask, 200 over 10 equal 20. F different than 10, then we have error in the preparation because we have no 10 times dilution, we have 20 times dilution. Then this is, here we have error. Here we have no error, we have imprecision. Then the most precise, the correct one and the most precise kit is kit 2. For kit 1, for kit 1, F equal 100 over 10 equal 10 times correct. But the use of a beaker instead of a volumetric flask makes the dilution non or imprecise. Then kit 1 is not appropriate or convenient. The kit that should be used is not appropriate or is not convenient for this dilution. For kit 2, F equal 100 over 10 equal 10 times. It is correct. And the use of volumetric pipe and volumetric flask makes the dilution precise. Then kit 2 is the convenient one for this dilution. Why kit 3 is not convenient? For kit 3, F equal 200 over 10 equal 20, bigger than 10. then this set pocket is not convenient for this dilution. Okay, then get to the convenient one. Now for part 3.2, another titration is carried out with S prime. Now we titrate the S prime by repeating the second step of the above experimental procedure and using another sodium hydroxide solution of concentration C prime B equal 4, 10 negative 3. Give by justifying the value of pH that corresponds to the volume VB equal 10 milliliter. Now, on page 3.2, we titrate the solution S prime of concentration C prime equals C over 10. That means equal, what equal the concentration of the solution S? Equal 4.16 10 negative 2. Then the concentration of solution S prime is 4.16 10 negative 3 mole per liter because we diluted it 10 times. We take the same volume, same procedure of step 2, then C prime equal 10, V prime equal 10 milliliter. We titrate it using sodium hydroxide solution of C prime equal, now in this case, C prime B equal 4 10 negative 3, 4 10 negative 3 mole per liter. بدي اخذ الحضور بس دقيقة، وانا اذا خلص الوقت انا بكفي السؤال وببعث لكم اياه، بس ما تظهروا لنخلص. اوكي، اللي بدنا نعمله هو بدنا نشوف الفوليوم at equivalence، هل بده يبقى 10.4؟ اذا بقي 10.4 يعني هيدا بيكون الفوليوم at equivalence، يعني البي اتش بيبقى 7. اذا لا معناتها بدنا نعمل كالكوليشن للبي اتش. طيب خلينا نعمل كالكوليشن للفي برايم اي at equivalence same titration. بما انه كتبناها بفيش داعي نرجع نكتبها، فيها دغري نقول في برايم اي ايكوال سي برايم، خلينا اي هون كلهم الاسيد اي والبيز بي، سي برايم بي في برايم بي اي، سي برايم اي في برايم اي over سي برايم بي equal 4.16 10 negative 3 times 10 over 4 10 negative 3. 10 negative 3 و 10 negative 3 بيطيروا، يبقى 4 على 4.16 يطلع 6، 10 بيطلع 10.4 مللتر. تتأكدوا منها انتم على بعدين. إذا volume at equivalent remains the same. Then V prime equal 10.4 milliliter equal VBE, then pH should be equal 7.